Okay, let's talk about some circles. So what I would recommend you do is probably pause this video as we go through so that you can make sure you get everything written down. So to start off, we have our terms. So this is all going to be the dictionary stuff. So a circle is the set of points equidistant from a given point, which is the center. So what you're going to want to make sure that you add to your picture over here is a point as close to the middle as you can make it. And we're going to label that point P. So that's our center. And so that's what we have here is circle P. And so the way we name that, you're going to see like a dot with a circle around it, and then the letter, that's whatever letter's at the center. And what that means, that's describing circle P. Sorry, that's supposed to say circle P. So that's the way we label a circle, is we put that little circle thing and then a capital letter for whatever point is the center of the circle. Next up, we have a radius. So a radius is a segment with endpoints at the center and on the circle. So we're going to have point P here in the middle again. And then we're going to have some other point that's on the circle. So I'm going to call that point A. And the radius is going to connect, well, it's supposed to connect point A and point P. Those are not very good points. Anyway, point A and point P, that's our radius. And you would just name it segment AP, connecting those. A chord is going to be a segment with endpoints on the circle. So if you have a point out here, maybe, we'll call this point K. And then we have another point out here, we'll call that point J, and we connect them. So these 2 points are on the circle. That is a chord. So it has to go through the center of the circle and just connect 2 points that are on the circle. A diameter is a special type of chord. So if a chord goes through the center, so I'm going to put that center back here, point P, that's the center again, and I have some chord that goes through point P, so I'm going to put a B here and an A on this one. So in this case, that chord that goes through the middle of the circle also goes through the center of the circle, which makes it a diameter. And as you guys have all seen at least once before, a diameter is double the length of a radius, or it's 2 times the radius, because it's like 2 radii going together. So anyway, that's a diameter. Next we have a secant. So a secant is a line that intersects the circle in exactly 2 places. So it's kind of like a chord that's extended. So if I put this that goes through here, whoops, sorry, wrong circle. So if I put this line that goes through here, do you see how it intersects the circle here and here? That's what makes it a secant. So I'm going to call this point Y and this point X. So that is what a secant does. It intersects the circle in 2 places. A tangent is going to be a line that intersects the circle at exactly 1 place. So if let's see, I'm going to put my tangent, let's draw it through that 1 point there. So I'm going to make that point Q. And if it's a line, we're going to put a couple other points on it. So I'm going to put, yeah, whatever, P, Q, and R. That's supposed to be another circle. Anyway, so if we have this line and it only touches the circle at point Q, that makes that line a tangent line. So I know that you've heard of tangents before with like SOHCAHTOA, but this is called a tangent line because it actually touches the circle at 1 point. So when people go off on tangents, they like find one thing to talk about and then they talk about it for a long time, while this is meeting the circle at 1 point and then going off on something different. So that's kind of a silly way to relate, but it doesn't make that much sense. Anyway, that's a tangent line. The point of tangency is the point where the tangent line intersects the circle. So if we redraw that same thing that we just had going on over here with PQR, so some line PQR, the point where that tangent line touches the circle, point Q, that's the point of tangency, is point Q. So just so that you're clear on that, a tangent line is the line that touches the circle at one point, but a point of tangency is the one point where the line touches the circle. Alright, we have a few more definitions here on the back, if I can get it to go. Alright, so first off we have a central angle on the back side. So a central angle is going to be an angle with a vertex at the center and two sides that are radii. So we start with our center here, which that's a little off center, but pretend like it's not. And so we have that radii, or radius, and this radius, and together that makes an angle. And so the central angle has its vertex. So point P is the vertex of that angle, and it's at the center. And then the two sides of the angle are going to be radii of the circle. An inscribed angle could have the same two endpoints. So if there's point A and point B, but the difference between an inscribed angle and a central angle is the inscribed angle also has a vertex that is on the circle. That's lovely. Let me try that again. So we have A, B, and then your vertex will be at C. So then you have an angle where both the endpoints and the vertex are on this circle. So because the sides of the angle go through the center, or through the middle of the circle, not the center, but the middle, that makes them chords. After that, we have an arc. An arc is going to be a portion of the edge of the circle defined by two endpoints. So if we put any two endpoints here, so if we have A here and B here, so those are supposed to be points. So we have A and B. The part of the circle that's between A and B, that portion there, that's an arc. So it's just a part of the circumference of the circle. And whenever we're naming an arc, the symbol that we use is going to be just an arc. So that's what you're going to see. There are a couple different types of arcs. A minor arc is going to be an arc with a measure of less than 180 degrees. So if we have A here and B here, and let's put C here. So if I'm just talking about the arc from A to B, that's going to be a minor arc. And so the way we name it is we use our symbol, and then we put the two endpoints under that symbol. So that's how we would say arc AB. A major arc, on the other hand, is going to be one that's 180 degrees or greater. So if we have that same thing going on here, A and B and C, so we put those all back, and we wanted to talk about this arc, so the one that goes from A and goes through C and then around to B, that's a major arc. And so the way that we name that arc that's differently than the little one is we put another point. So you have your endpoints, A and B, but then you have to put some other point that's along the circle, and then you put your arc over it. So that whole arc there, going from A around through point C and then back to B, that's a major arc because it's more than 180 degrees, and so we call it arc ACB. And the last definition we have here is a semicircle, and a semicircle is an arc with endpoints on the diameter. So if we have this point, here's our center, and this point, so this from J to L is the diameter. We put point K here. This right here, that's 180 degrees. That's half of a circle. That's a semicircle. So that's always going to be 180 degrees, and we name it with 3 letters. So that's arc JKL. So it's half of the circle. It's a semicircle. So there are your definitions. A few important formulas that we're going to be using. We have area of a circle, which is pi r squared, where r is the radius. We have circumference, and you have two different options here. Circumference equals 2 pi r, where r is the radius, or you can use the fact that circumference equals pi times diameter. So remember that the diameter equals 2 radii. So that's where either of those work, just depending on what information you have. And then the last formula there, which we're going to talk about more in a little bit, is arc length. So you use a cursive lowercase l, so L equals x times c divided by 360. And x is going to be the degree of the arc, c is the circumference of the circle, and then 360 degrees. So that's how you find arc length. And again, we're going to go more into that later, but this is your dictionary information.